My name is Mimi Afrina and I'll be presenting the introduction for our mini project on acid rain in Klang Valley. Acid rain forms when sulfur dioxide and nitrogen oxide are released into the atmosphere and react with water vapor to produce sulfuric and nitric acid. When this falls as precipitation, it has a pH value below 5.6 and that's what we call acid rain. So in the Klang Valley, rainfall pH has been recorded as low as 4.4, which is classified as extremely acidic. So study shows that acidity levels here peak between the year 2000 and 2005. Main pollutants are SO2 and NO2 produced from the combustion of fossil fuel in automobiles, power plants and factories. So once in the atmosphere, they form acids that fall as wet deposition or called acid rain. So the long-term data confirms these local emissions are the dominant contributors to rainfall acidity in Klang Valley. We chose 2020 to 2026 because it's a unique period. The COVID-19 MCO in March 2020 caused a sharp drop in emissions and improved air quality. So as the economy recovered, emissions rebounded, giving us a clear before and after picture of how human activity affects acid rain. So we will be analyzing this using NASA Earth Data Satellite datasets. The importance of this study is that we know the effect of acid rain in three aspects. So first, ecologically, it lowers soil and water pH, reducing its biodiversity. And next, for public health, SO2 and NO2 cause respiratory illness such as asthma and can contaminate drinking water. And lastly, for infrastructure, it corrodes buildings and historical monuments, which is a major concern in a dense urban area like Klang Valley.
Thank you for the introduction. For my part, I am responsible for defining our study area, acquiring the datasets, and methodology. We selected the Klang Valley region, which is the economic and industrial heart of Malaysia, making it an ideal candidate for monitoring urban air pollution, where our target pollutant is nitrogen dioxide and sulfur dioxide. Tracking these specific gases is crucial because high concentrations of these gases are the main indicator to acid rain. The geographic boundary spans from 2.9 to 3.5 degrees north and 101.3 to 101.9 degrees east. Our study tracks a 6-year timeline from the start of 2020 through June 2026, allowing us to observe variations across major economic shifts. We retrieve daily data using NASA's Giovanni platform, utilizing the Ozone Monitoring Instrument or OMI. On board of it, we also use NASA's Aura satellite. We specifically focus on two key criteria air pollutants, which is the tropospheric nitrogen dioxide, measured in molecule per square centimeter, and atmospheric sulfur dioxide, measured in Dobson units. Next, from methodology, our workflow followed a 4-step pipeline: extraction, processing, compilation, and visualization. First, we configured our spatial constraints directly into Giovanni to filter out noises from outside the Klang Valley. Then, we generated daily area average time series along with baseline spatial heat maps to verify regional hotspots. Next, we exported these massive daily data arrays into Microsoft Excel. This is because daily satellite data fluctuates rapidly due to cloud cover and weather anomalies. We use Excel pivot tables to aggregate the daily points, and by calculating the mathematical mean for each calendar year, we successfully smooth out seasonal anomalies to isolate clear long-term trends. And finally, we transform these pivot tables into the clean bar charts, enabling a direct year-to-year analysis of how this gas evolved from 2020 to mid-2026.
Now, let's look at the actual data we collect from NASA. If you look at the first bar chart, you can see that pollution level changed a lot from year to year. In 2021, gas like N2O dropped to their lowest level. This happened because of the COVID MCO lockdowns in Malaysia, which took car off the road and temporarily shut down factories. But notice what happened from 2022 to 2025. As soon as business went back to normal, pollution increased directly and peaked because of heavy city traffic and power plants. Next, let's look at the geographic map on our second slide. The bright orange color show exactly where the harmful air pollution is. As you can see, it is tightly stuck directly inside the Klang Valley boundaries. This is caused by environmental, physics and weather. When seasonal winds are slow, the hills around the valley trap the smoke and exhausted gas right over the city. This gas then mix with rain clouds and create acid rain. Also, the small drop you see in year 2026 is just because our data source end in June, so it only counts off of the year. To summarize, our data prove that Klang Valley acid rain is heavily tied to daily city traffic and local weather trapping the gas.
So now, let's moving on to the next part of our presentation. Let's look at how we can address this issue. We can focus on the three main steps. First, use cleaner transportation. Since cars and motorcycles cause a lot of pollution in the Klang Valley, taking public transport or driving electric vehicle will cut down these harmful gases. Second, improve industrial technology. We need factories and power plants to use modern filters to clean their exhaust before it reaches the air. Third, transition to renewable energy, moving away from burning coal and oil and shifting to solar power will fix the problem at its root source. By doing these three things, we can protect our health, our building, and our environment from acid rain.
So lastly, the conclusion to our presentation. So we analyzed the NO2 and SO2 trends in Klang Valley from 2020 to mid-2026 using NASA satellite data. So the pollution dropped significantly in 2020 until 2021 due to COVID-19 MCO restrictions. Meanwhile, emissions rebounded and peaked at 2024 with resumed traffic and industrial activity. And during partial 2025 till 2026, data suggests slight stabilization, but acid rain risk still remains high. So the recommendations that we can do to ways to reduce acid rain is that to expand public transport and promote EVs, enforce stricter industrial emission standards, and combine satellite plus ground monitoring. And lastly, remote sensing also proved effective for tracking regional air pollution despite cloud cover limitations. And that's all from our presentation. Thank you.